higher boranes. And we have already discussed boron, form or series of hydrides. Those hydrides of boron which contain more than two boron atom are called polyborane or higher boranes. Okay, polyborane are higher boranes. Okay, those hydrides of boron, those those hydrides, those hydrides of those hydrides of boron which contain more than two boron, which which contain more than more than which contain more than two boron which contain more than two boron atom which contain more than two boron atom are called are called polyborane. Poly polyborane are higher borane are higher borane. Okay, as an example, B4H10 tetraborane tetraborane tetraborane. Okay, tetraborane and tetraborane 10 and B5H11 pentaborane 11 pentaborane 11 and B6H12 hexaborane 12 hexaborane hexaborane 12. Okay, in the monomolecular, okay, in the nomenclature of higher boranes, the prefix is written on the basis of borane atom, and after the name, the number of hydrogen atom is written with small brackets. Okay, in the nomenclature of higher boranes, in the nomenclature, in the nomenclature of higher boranes, higher boranes. Okay, in the nomenclature of higher boranes, the prefix is written. The prefix is written on the basis of boron atom, and after the name and after the name the number of hydrogen the number of hydrogen atoms is written within small brackets. Okay, method of preparation, methods of preparation. Okay, method of preparation. Okay, higher boranes are obtained by the thermal decomposition reaction. All boranes undergo complex reversible reactants at 100 to 250 degrees Celsius. The higher boranes are obtained by heating. The higher boranes are obtained by thermal decomposition reaction. Higher boranes are obtained by thermal decomposition. Okay, thermal decomposition. Okay, higher boranes are obtained by thermal decomposition. All boranes undergo complex reversible reaction at 100 to 250 degrees Celsius. All boranes undergo All boranes undergo complex reversible all boranes undergo complex reversible reaction at 100 to 250 degrees Celsius. Okay, the higher boranes are obtained by heating B2H6 with hydrogen under the specific condition except hexaborane 10. The interconversion of boranes, you can show this. The interconversion of boranes, you can show this is a B2H6. You can listen carefully. The higher boranes are obtained by heating B2H6 with hydrogen under specific condition except hexaborane 10. The interconversion of boranes you can show. Okay, this is B2H6 at 180 degrees Celsius, that make B5H9, and 120 degrees Celsius B5H11, and B10H14 at 150 degrees Celsius, and this is inverse reaction, action to reaction. Okay, and at 100 degree Celsius B4H10. Okay, B4H10, and you can achieve B4H10 by, you can achieve B10H14 by the help of B4H10 at 90 degree Celsius. Okay, 90 degree Celsius, and you can achieve B10H14 from the B5H11 at 250 degrees Celsius. 250 degrees Celsius. Okay, and you can achieve B4H10 at 200 degrees Celsius, B5H9. Okay, higher boranes are synthesized by heating B2H6 something with hydrogen. When B2H6 is heated in a closed tube, then complex reaction takes place. Consequently, higher boranes are formed. Example: B4H10, B5H11, and B10H14, etc. Okay, etc. First point you can show how to achieve. First point, B4H10 tetraborane 10. Okay, tetraborane 10. Point A. Okay, Stark's method. Okay, Stark's method. When magnesium bromide is treated with a dilute acid mixture of boranes is obtained, the chief constituent in the mixture is B4H10. Okay, Mg3b2. Okay, magnesium bromide. This is magnesium bromide. Okay, magnesium bromide, Mg3b2 magnesium bromide plus HCl hydrochloric acid, that make with dilute acid hydrochloric acid B4H10. This is the mixture of boranes obtained. This is chief constituent. Chief constituent of mixture plus B5H9 plus B5H11 plus B6H10 and next is 2Mg3B2 plus 12HCl that make B4H10 plus 6MgCl2 plus H2 okay, MgCl2 plus H2 okay. And next, the tetraborane is separated from this mixture by fractional distillation. Okay, tetraborane is separated from this mixture by fractional distillation. Okay, tetraborane, you can listen carefully. Tetraborane is separated from this mixture by fractional distillation. Okay. Next point number B. When B5H11, 1 minute. When B5H11 is heated with hydrogen at 100 degrees Celsius, okay. B5H11, when B5H11 is heated with hydrogen at 100 degrees Celsius, that make 2B4H10 plus B2H6, okay, and at 100 degrees Celsius tetraborane is obtained. This is tetraborane, okay. When B5H11 is heated with hydrogen at 100 degrees Celsius, at 100 degrees Celsius, okay, at 100 degrees Celsius that make, okay, and tetraborane. This is tetraborane, okay. C point, 2B2H6 at 200 atm pressure and heating at 80 to 90 degrees Celsius for 5 hours that make B4H10 plus H2. That means if we heated the B2H6 diborane at 200 atm pressure and 80 to 90 degrees Celsius temperature for 5 hours, then that make B4H10 plus H2. That means tetraborane plus hydrogen gas. Next heading, it is very important heading. Next very important, and I look exam, okay, board exam, okay, by board reaction. D point, board reaction, okay, board reactions, okay, reaction, very important. Board's reaction, okay. 2B2H5I plus 2NaRHG that make B4H10 plus 2NaI sodium iodide, tetraborane sodium iodide. Second point, pentaboranes, okay. When diboranes is thermally decomposed at 250 degrees Celsius, then pentaborane 9 is obtained, okay. When diborane B2S6 is diborane is thermally decomposed at 250 degrees Celsius, then that make 2B5H9 plus 6H2 and 5B2H6 at 250 degrees Celsius and 120 mm pressure. 20 mm pressure, closed tube, closed tube, closed tube that make B5H9 plus B5H11 plus 5H2. Okay, and when diborane is passed from U tube at 115 degrees Celsius, pentaborane 11 is obtained. Pentaborane 11 is obtained. 5B2H6 at 115 degrees Celsius U tube that make 2B5H11 plus 4H2. Okay. Third point. B10H14 decaborane 14. When diborane is thermally decomposed in a closed tube at 150 degrees Celsius, and decaborane 14 is obtained. Okay, 5B2H6 at 115 degrees Celsius. Okay, closed tube that make B10H14 plus 8H2. Okay. Next heading, general properties. General properties of diborane. General properties of diborane. Okay. General properties. General properties. Okay. First point. Many higher boranes are liquid, but B6H10 and B10H14 are solid. Okay, many higher boranes are liquid. Many higher boranes are liquid. Many higher boranes are liquid, but B6H10 and B10H14 are solid. H14 are solid. Okay. Second point. Their stability in atmosphere increases with increase in molecular weight. Okay. Their stability in atmosphere increases with increase in molecular weight. With increase in molecular weight. Okay. Third point. B4H14 is inert in air. Okay. B10H14 is inert in air. Fourth point. B4H14 and B5H11 reacts rapidly with water, while B5H9, B6H10 and B10H14 slowly hydrolyzed. Okay. B4H10 and B5H11 react rapidly with water. React rapidly with water. While B5H9, B6H10 and B10H14 slowly hydrolyzed. Okay. Then B4H10 plus 12H2 that make 4H3BO3 plus 11H2, and B4H10 plus 4KOH plus 4H2O, that make 4KBO2 plus 11H2, and B6H12 plus 18H2O, that make 6H3BO3 plus 15H2, and B6H12 plus 6KOH plus 6H2O, that makes 6KBO2 plus 15H2. Okay, fifth point, 5 point. Lewis base CH3Cn reacts with decaborane and liberate hydrogen gas 2CH3Cn plus B10H14, that make B10H12 into 2CH3Cn plus H2. Hydrogen gas liberates. Okay, hydrogen gas liberates. Okay, and the important properties of boron you can show. Okay, 1 minute. Important property of boron you can show. Okay, the important properties of borans. B2H6 diborans, B2H6 melting point 160 minus 165 degrees Celsius and boiling point 93 degrees Celsius. Okay, and thermal stability is stable at 25 degrees Celsius, and reaction with water instant hydrolysis. Okay, and B5H9 minus 47 degrees Celsius, melting point, boiling point 60 degrees Celsius, and thermal stability at 25 degrees Celsius, hydrolysis and heating. Okay, B6H10 minus 60 degrees, 62 degrees Celsius, 108 degrees Celsius, slow decompose at 25 degrees Celsius, thermal stability, and reaction with water, hydrolysis and heating. Okay, and B10H14 melting point 100 degrees Celsius, boiling point 213 degrees Celsius, stable at 150 degrees Celsius, and slow hydrolysis. Hydroboranes B4H10 melting point minus 120 degrees Celsius, boiling point 80 degrees Celsius, and thermal stability decomposed at 25 degrees Celsius, hydrolysis in 24 hours. Okay, and B4H11 melting point minus 123 degrees Celsius, boiling point 63 degrees Celsius, decomposed at 25 degrees Celsius, rapidly hydrolysis. B6H12 minus 82 degrees Celsius, melting point, boiling point 90 degrees Celsius, thermal stability liquid, stable for few hours, and reaction with water, hydrolysis. Okay, 6 point. This behaves as an acid and form anions by releasing protons. Decaborane behaves as a strong monoprotic acid. Okay, B10H14 plus NaH, that make NaB10H13 plus H2. Okay, 7 point. Tetraborane forms hypoborane in alkaline solution. B4H10 plus 4KOH. Okay, that make 4KOBH3 plus H2. 8 point. Hydrogen atom of boranes are replaced by carbonyl group. Okay, B4H10 plus CO, carbon monoxide, at the heating that make B4H8CO plus H2 plus H2. Okay, next one. Tetraborane are very unstable and decomposed at room temperature. Tetraborane are very unstable and decomposed at room temperature. B4H10 at room temperature that make B2H6 plus H2 plus other boron hydrides, other boron hydrides, other boron hydrides. Okay. Next, structure of higher boranes. Structure of higher boranes. Okay. Structure of higher boranes. Structure of higher boranes. Higher boranes. Structure of higher boranes. Okay. Higher boranes are also electron deficient compounds and these also contain bridge structures. Okay. The higher boranes have an open cage structure. In order to explain the structure and bonding of the higher boranes, 5 bonding elements are required. Okay. The 5 bonding elements required for explaining the structure of higher boranes are given as follow. First point. Okay. First point, okay. Terminal 2C2E BH bond, okay. Terminal 2C2E BH bond, okay. BH bond. Second point, 3C2E hydrogen bridge bond, okay. HBB, okay. Third point, 2C2E boron bond. Fourth point, open 3C2E boron bridge bond, okay. Fifth point, closed the 3C2E boron bond, okay. Higher boranes possesses multi-center bonds covering boron atoms and boron hydrogen boron bridge. With the help of 5 elements of bonding, Lipscomb in 1963 suggested semi-topological schemes for the structure of all boranes. The structure of some important boranes have been, you can see point A, B4H10 tetraborane 10, okay. In B4H10, these are 4 tetraboranes boron. These are 4 tetraboranes. In B4H10, there are 4 tri-centered boron hydrogen boron bond 3-centered 2 electron bond, okay. 1 boron bond and 2C2E boron hydrogen bonds. B point, pentaboranes, okay. 9, B5H9, okay. In this molecule 5 boron atoms. 5 boron atoms. 5 boron atoms. 5 boron atoms lie on the 5 corners at a square pyramid. Lie on the 5 corners of a square pyramid. Of a square pyramid. Square pyramid. Okay. In B5 page 9 there are 4 tri-centered BHB bonds. Okay. In B5H9 there are 4 tri-centered boron hydrogen boron bonds, 3 centered 2 electron bonds. Okay, and 4 atoms and 4 boron atoms are joined to one boron atom. It also possesses 5 terminal boron hydrogen bond, 2 boron bonds, and 1 boron bond. Okay, point C. Okay, point C, and you can also see. Okay, and next borojol or borogene. Inorganic benzene, borojol or boragine or inorganic benzene. Okay, next point borajol. Next point borajol. Next point borajol. Next point borajol R. Borajol R. Borogene. Borojol R. Boragine R. Inorganic benzene. Inorganic benzene. Okay, inorganic benzene. B3N3H6. Borojol is an inorganic compound which has cyclic structure similar to benzene with alternate single and double bonds. Hence, it is also called inorganic benzene after Weiberg in 1940. Method of preparation. Method of preparation. Okay, method of preparation. First point, when diborane and ammonia in the ratio, when diborane B2H6 and ammonia NH3, ammonia in the ratio 1:2 are heated at 120 degrees Celsius, adduct diborane ammonia B2H6 into 2NH3 is obtained. Okay, this adduct decomposes to give borajol at 20 degrees Celsius. Okay, this adduct decompose at 200 degrees Celsius. Start and fill in the method. Okay, then 3B2H6 plus 6NH3 at 120 degrees Celsius. That makes 2B2H6 into 2NH3 at 200 degrees Celsius. That makes 2B3N3H6 plus 12 H2, 12 H2. Okay. Okay. Second point. This is obtained by the reaction of NH4Cl, ammonium chloride, and BCl3, boron trichloride, as follows. Okay. Then 3NH4Cl, ammonium chloride, plus 3BCl3, that at C6H5Cl, that make a B3N3Cl3 H3, and NaBH4 ether, okay, ether, B3N3H6. Okay. Third point. Laboratory method. Okay. Laboratory method. How to prepare the borazole by the help of a laboratory method? When LiBH4, lithium borohydride. This is lithium borohydride is heated with NH4Cl, at 230 degrees Celsius temperature in vacuum, that make borazole is obtained. B3N3H6 plus 3LiCl plus 9H2. Properties. First point. It is liquid. It is isoelectronic with benzene. It is isoelectronic with benzene. Isoelectronic with benzene. Okay. Isoelectronic with benzene. Okay. Benzene. This is benzene. Isoelectronic with benzene. Okay. Benzene. 1, 2, 3, 4, 5, 6, and 1, 2, 3, HB, HN, BS, NS, BS, NS, inorganic benzene. This is inorganic benzene. That make 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3. HN, BS, NS, BS, NS, HB. Okay. Inorganic benzene. This is inorganic benzene. Okay. Third point. Third. Like benzene, borazole is colorless liquid with aromatic smell and solvent properties. Okay. Aromatic smell and solvent properties. Okay. Aromatic smell. Like benzene, borazole. Borazole colorless. and liquid, colorless liquid with aromatic smell, aromatic smell and solvent properties, solvent properties, okay. Fourth point, it is slowly hydrolyzed by water, it is slowly hydrolyzed by water, it is slowly hydrolyzed, it is slowly hydrolyzed by water, okay, by water, giving boric acid and ammonia, B3N3H6 plus 9H2O, that gives 3H3BO3, boric acid. This is boric acid plus 3NH3, ammonia, and plus hydrogen 3H2 hydrogen, okay. Fifth point, it forms adduct with a hydrochloric acid which on heating at 50 to 100 degrees Celsius give beta trichloroboragine, B3N3H6 plus 3HCl plus 3HCl, that makes B3N3H9Cl3 at 50 to 100 degrees Celsius, that makes B3N3H3Cl plus H3H2 plus 3H2. This is beta trichloro. This is beta trichloro. This is beta trichloroboragine. Beta trichloroboragine. Okay. 6 point. It also forms addition compound with bromine at 0 degrees Celsius, which on heating at 60 degrees Celsius gives beta trichloroboragine. Okay, B3N3H6 plus 2Br2 at 0 degrees Celsius, that make B3N3H6 Br6 at 60 degrees Celsius, B3N3H3 Br3 plus 3HBr. This is beta trichloroboragine, beta trichloroboragine. Okay. 7 point. Boragine undergoes addition reaction. B3N3H6 plus 3HX, that makes minus H2N minus BHX minus 3 where? Sorry. Single bond H2N, single bond BHX, single bond bracket close, and 3 where X equal to chlorine OR. Okay. Structure. Next point. Structure. Okay. Structure of boragine. Okay. Structure of borazole. Structure. Borazole resembles benzene in physical and chemical properties and structure also for the following reasons. Point A. You can listen carefully, okay? In borazole, 6 carbon atom of benzene. 6 carbon atom of benzene. 1 minute. Structure of boragine. Okay, boron, nitrogen, boron, nitrogen, boron, nitrogen, boron. Okay, hydrogen, 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 hydrogen. Okay, one, two, three, one, two. Okay. In borojol, 6 carbon of benzene. 6 carbon of benzene are replaced by 3 boron. 1, 2, 3. 3 boron and 3 nitrogen. 1, 2, 3 nitrogen atom. Thus the total number of valence electron in borojol and benzene are equal. Okay, B point. Borojol also possesses 3 double bonds like benzene. 3 double bonds like benzene. Okay. In benzene, 6 pi electrons is uniformly delocalized in the benzene ring. On the other hand, in borajol, the 6 positions are not identical because of the electronegativity difference between boron and nitrogen. Boron and nitrogen. This gives rise to polarity in borajol molecules. Hence, borajol should be more reactive than benzene. Borajol readily undergoes addition and substitution reaction, but benzene is very resistant to addition reactions. Borajol is a cyclic compound and contains alternate boron, hydrogen and NH group. It is a hexagonal planar like the organic benzene. The resonance structures first and second gifts below are supported by electron diffraction. IR and Raman spectra. The boron nitrogen distance 1.44 angstrom. Boron nitrogen distance. The boron nitrogen distance 1.44 angstrom lies between that for the single bond 1.54 angstrom and double bond 1.36 angstrom. The lone pair on each nitrogen atom is capable of contributing to either of 2 boron-nitrogen linkage. In inorganic benzene or borajol, each boron and nitrogen atoms are sp2 hybridized just like each carbon atom of benzene, which is also in sp2 hybridizations. The boron, hydrogen and nitrogen bond length are 120 angstrom and 1.02 angstrom. The bond angle is about 120, which is due to hexagonal ring structure of boragine. The bond angles can be explained on the basis of the sp2 hybridization of 3 boron and 3 nitrogen atoms. Okay, resonating structure of benzene and borajol. Okay. You can show 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3. 1, 2, 3. Hydrogen, 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 hydrogen. Okay. After some time, this is 1, 2, 3, 4, 5, 6, and 1, 2, and 3. This is hydrogen, 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 this is hydrogen. Okay? And after some time, triple bond, 1, 2, 3, 4, 5, 6. Okay? Okay. This is resonating condition, benzene. Okay? First, second. Okay? Resonating condition. Hydrogen, 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 hydrogen. This is benzene. This is benzene. Benzene. Okay? This is benzene. And 1, 2, 3, 4, 5, 6. Okay? That's why nitrogen, boron, nitrogen, boron, nitrogen, boron. Okay? Single bond, and after some time okay, hydrogen plus hydrogen minus hydrogen, 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 hydrogen. Okay, this is first step. This is first step. Okay, and after nitrogen, boron, nitrogen, boron, nitrogen, boron. Okay, hydrogen, 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 hydrogen. Okay? Okay. 1, 2, 3, 4, 5, 6. This is nitrogen, boron, nitrogen, boron, nitrogen, boron. Okay? Hydrogen, 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 hydrogen. Okay? Resonating condition. Okay? This is borazole. This is borazole. This is borazole. Okay? This is resonating structure of benzene and borazole. Okay? And borohydrides. Next point, borohydrides. Next point, borohydrides. Borohydrides. Okay? Borohydrides. Borohydrides. Okay? Borohydrides. Next point, borohydrides. Okay? Next point, borohydrides. Okay? The stable complexes containing the group BH4 are called borohydrides. They are also called tetrahydroborates or hydroborates, but less frequently. The old name borohydride is still widely used. The borohydride ion BH4 ion has tetrahedral structure. Sodium borohydride is the most important compound. There are so many metallic elements: beryllium, magnesium, aluminum, and zirconium, thorium, and uranium, etc., which form borohydrides. The different borohydrides do not show similarities among each other. This is because the metallic components which is attached to BH4 species determines the properties of borohydrides. Borohydrides have been classified as alkali metals borohydrides. Okay? Alkali metals, alkali metal borohydride, alkali metal borohydride, alkali metal borohydride. Okay? Alkali metal borohydride. Sodium borohydride is prepared by the reaction of trimethyl borate with sodium hydride at high temperature. Okay? 4NaH, sodium hydroxide plus CH3 whole thrice BO3, 250 degrees Celsius, THF solvent. THF solvent. Okay? THF solvent means trimethyl borate. Trimethyl borate. Okay? that make and by obtained NaBH4 plus 3CH3 3CH3ONA. Okay, sodium hydride. Okay, sodium hydride. Okay, and lithium and sodium borohydrides are prepared by following method: 2LiH plus B2H6 ether. Okay, ether that make 2LiBH4 plus 4NaOH plus 2B2H6 ether that make NaBH4 plus NaBOH whole 4. Okay. Potassium borohydride is prepared as follow: NaBH4 plus KOH C2H5OH ethanol KBH4 plus NaOH. The alkali metals borohydrides are colorless ionic solid. The borohydrides react with water with varying ease. Lithium LiBH4 reacts violently with water. LiBH4 plus 2H2O that make LiBO2 plus 4H2. Sodium borohydrides NaBH4 may be recrystallized from cold water with only slight decomposition, but KBH4 is quite stable with water. The alkali metal borohydrides are valuable reducing agent in organic synthesis. Alkali metals borohydrides reduce carbonyl compounds to corresponding alcohols. Okay. Then RCHO NaBH4 RCH2OH 1 degree alcohol, that is 1 degree alcohol. Okay, R C double bond O at NaBH4 that make RCHOH. Okay, 2 degree alcohol, that is 2 degree alcohol. Okay. Point B. Alkaline metal borohydride. Alkaline metal borohydride Beryllium borohydride is obtained when beryllium chloride reacts with sodium NaBH4 at a high temperature. BeCl2 plus 2NaBH4 at a high temperature that make BeBH4 whole twice plus 2NaCl, sodium chloride. Okay, and beryllium borohydride is covalent and volatile in nature. It is violently hydrolyzed by water and HCl. Magnesium borohydride is prepared as follows: 3Mgr2 plus 4B2S6 that ether 3MgBH4 whole twice plus 2Br3. Okay, it is a white crystalline solid having melting point melting point 180 degrees Celsius. It reacts with hydrochloric acid at lower temperature and produces diborane okay, and produces diborane MgBH4 whole twice plus 2HCl, that makes ether minus 40 degrees Celsius, B2S6 plus MgCl2 plus hydrogen. Okay. Higher alkaline earth metals, calcium, strontium, barium also form borohydrides. Their borohydrides are thermally more stable, and BaBH4 decomposes at 400 degrees Celsius. Decomposes at 400 degrees Celsius. Point C. Other metal borohydrides. Other metals borohydrides. Other metals borohydride. Other metals such aluminium, uranium, titanium, zirconium, etc. also form borohydrides. Aluminium and uranium borohydrides are prepared as follows: AlCl3, aluminum trichloride plus 3NaBH4, that heating at high temperature, and AlBH4 whole thrice plus 3NaCl. Okay, and UF4 uranium tetrafluoride plus 2AlBH4 whole thrice, heating at high temperature, uranium UBH4 whole 4 plus 2AlF2 into BH4. Aluminium and transition metals of borohydrides are covalent and volatile in nature. The structure of aluminium and beryllium. Next point. Okay. Sodium hydride is most important and representative compounds of alkali borohydrides. The detailed chemistry of NaBH4 is studied separately as follows. Method of preparation. Okay. Okay. First point. First. Method of preparation. First point. Okay. By the reaction of sodium hydride and trimethyl borane, 4NaH, sodium hydride plus BOCH3O3, trimethyl borate. This is trimethyl borate, that makes NaBH4 plus 3CH3OONA. Second point. By the reaction of sodium tetramethyl borohydride and sodium hydride, okay, 3NaH. Second point, 3NaH, sodium hydride. Sodium hydride plus NaBH4OCH3 whole thrice. Sodium trimethyl borohydride. Sodium trimethyl borohydride. Sodium trimethyl borohydride. Okay, sodium trimethyl borohydride, that makes NaBH4. Sodium borohydride. Sodium borohydride plus 3CH3ONA, sodium methoxide, sodium methoxide, sodium methoxide. Third point, third point, third point. By the reaction of a methoxy ion on a borine radical, 3OCH3, that is methoxy ion, methoxy ion plus 4BH3, borine radical, borine radical, that makes 3BH4, okay. Borohydride ion, borohydride ion, borohydride ion plus BOCH3 all thrice trimethyl borate, trimethyl borate, okay. And the above process following reactions occurs, NaBH OCH3 all thrice plus BH3, that make NaBH4 plus BOCH3 all thrice, okay. 3NaBOCH3 all 4 plus 4BH3, that is 3NaBH4 plus 4BOCH3 all thrice, okay. And the next point, 3NaOCH3 plus 4BH3, that makes 3NaBH4 plus BOCH3 all thrice. Physical properties. Next point, physical properties, okay. Physical properties. Physical properties, okay. It is colorless, okay. It is colorless. What colorless? Borohydrides. Physical property of borohydrides, okay. It is colorless, ionic solid, and it is stable up to 400 degrees Celsius in vacuum. It is stable up to 400 degrees Celsius in vacuum, and 300 degrees Celsius in air, okay. It is soluble in isopropylamine and liquid ammonia. It is soluble in isopropylamine and liquid ammonia. It is insoluble in ether and dioxin. It is and insoluble in it is insoluble in ether or dioxazone, okay. And chemical properties, okay. Chemical properties of borohydrides, okay. Borohydrides. Chemical properties of borohydrides. First point, hydrolysis. First point, hydrolysis. Hydrolysis, okay? It is decomposed with cold water and produces hydrogen gas. It is rapidly hydrolyzed with hot water, okay? Then 3NaBH4 plus 6H2O, that make 12H2, okay? 12H2, okay? 12H2O, that make 12H2 hydrogen gas plus Na3B3O6, action of hydrochloric acid. Second point, action of hydrochloric acid. Hydrochloric acid, action of hydrochloric acid. Diborane is found by action of hydrochloric acid, okay? Hydrochloric acid, 2NaBH4 plus 2HCl, that make 2NaCl plus diborane B2H6 plus 2H2 hydrogen gas, okay? Third point, action of methyl alcohol. Action of methyl alcohol, action of methyl alcohol, okay? In this reaction, hydrogen gas is liberated, okay? Then NaBH4 plus 4CH3OH, minus 40 degrees Celsius, and NaBOCH3 whole 4 plus 4H2, okay? This reaction occurs at 40 degrees Celsius. This reaction occurs at 40 degree minus 40 degrees Celsius. Fourth point, point 4. Reaction with boron trifluoride ethate. Okay? In this reaction also diborane is formed. Fifth point, reaction with iodine. Boron triiodide is formed with ionic iodine at 200 degrees Celsius. NaBH4 sodium, NaBH4 plus 4I2, that make 200 degrees Celsius. Bi3 boron triiodide plus NaI sodium iodide plus 4Si, okay? Hydrogen iodide. Sodium borohydride is useful as a reducing agent in weak alkaline medium, because later on it is destroyed by the adding acid. This is weak reducing agent in comparison to lithium LiBH4 or LiAlH4. This is more selective. Also, it is slowly decomposed by water and alcohol. It is a specific reducing agent for aldehydes, ketones, and acid chlorides. It does not attack on other reducing groups like ester, epoxides, lactone, carboxylic group, nitriles, and nitro groups. In aqueous solution, it is applicable in the reduction of carbonyl compounds. It is widely used in carbohydrate chemistry. 4R2CO plus NaBH4 plus 3H2O, that make 4R2CHOH plus NaH2BO3, okay? Important usage of sodium borohydride. Okay? Important usage of sodium borohydride. 1 minute. Important usage of sodium borohydride. Important usage of sodium borohydride. Okay. First point, reduction of aldehyde and ketones. Reduction of aldehyde and ketones. It is reduces carbonyl compounds to corresponding alcohol. Okay, CH3, CO, CH2, C double O, CH3. This is acetyl acetone. This is acetyl acetone, acetyl acetone at NaBH4 CH3 CHOH CH2 CHOH CH3. This is pentane-diol. Pentane-diol 2,4. Okay, and CH3 and CH3 CH double bond CH single bond CHO. Okay, aldehyde समूह. Okay, crotonaldehyde. This is crotonaldehyde at NaBH4 CH3 CH double bond CH single bond CH2OH. Okay, crotyl alcohol. This is crotyl alcohol. Okay, and CH2OH CHOH CHO. This is glucose. Okay, at NaBH4 CH2OH CHOH 4CH2OH. Okay, that is sorbitol. Okay, sorbitol. Okay, as we have already discussed that it does not affect on carboxylic ester, amide, nitrite, nitro etc. group. Hence, it reduces benzoyl propionic acid to gamma hydroxyl phenyl butyric acid. Okay, butyric acid C6H5 COCH2 CH2 COOH. Okay, this is benzene. This is benzoyl propionic acid. Benzoyl propionic acid at NaBH4 CnCH2 CH2OH. This is gamma cyano propyl alcohol. Gamma cyanopropyl alcohol. 1, 2, 3, 4, 5, 6. Okay, 5, 6. Okay, this is NO2, and this is CHO. Okay, pyronitro benzaldehyde. NaBH4 1, 2, 3, 4, 5, 6. Okay, NO2 CH2OH. This is pyronitro benzyl alcohol. Okay, next point, reduction of ozonides. Okay, reduction of ozonides. Okay, reduction of ozonides, reduction of ozonides, reduction of ozonides, reduction of ozonides, okay? Reduction of ozonides, okay? This is cyclohexane. This is cyclohexene, O2 oxygen, 1, 2, 3, 4, 5, 6, okay? O, okay? Cyclohexene, ozonides, NaBH4, okay? OH, cyclohexane 1.6 diol, okay? Reduction of oxides. If sulfur is present in oxide molecule, then it cannot be reduced as amine. The reduction of these types of compounds has been done by NaBH4 in presence of isopropyl alcohol by reflux. Okay, synthesis of alkyl borates. Okay, 2C4H9OH plus NaBH4 plus CH3COOH, that is C4H9 whole thrice BO3, tributyl borate, plus CH3COONA plus hydrogen. Tributyl borate is a polystyrene. Preparation of brown and brown catalyzed powder black precipitate of pure platinum is called brown and brown catalyzed. It is prepared by adding NaBH4 in 10% solution of chlorofluorinatic acid. It is an active catalyst for diphene and acetylene. 6 point preparation of diborane. Preparation of diborane. Diborane is obtained by the action of NaBH4 and boron trifluorides. Okay, 4BF3 plus 3NaBH4, that makes 2B2H6 plus 3NaBF4. This is diborane and this is sodium borofluoride. And BF2 plus 3NaBH4, that makes 3B2H6 plus 3NaF. Hydroboration during the reaction. Hydroboration is done with the help of NaBH4 in diethylene glycol or dimethyl ether or tetra hydrofurate THF solvent. Okay, 4BF3 plus 3NaBH4 plus 12RCH, double bond CH2, that 4RCH2 whole thrice B plus 3NaBF4. Thank you, students. This chapter is ended, and next chapter we will be studying in the next lecture. The next chapter name is Key Black Elements Part Second. Okay.